Welcome to This Explainer. I'm absolutely thrilled to have you here today because honestly, we're tackling a truly fascinating challenge. We are not just talking about buying a glass box and throwing some salt water in it. No way. We're talking about the intricate step-by-step process of engineering a living, breathing ecosystem right from scratch.
So I really want you to think about this question for a second. What does it actually take to engineer a piece of the ocean in your living room? Designing a custom reef aquarium is this beautiful tightrope walk between high-end aesthetics and serious mechanical engineering. And here's the catch. Custom reef systems, they are totally unforgiving when your water parameters start to drift. You can't just wing it, because the stakes for this living ecosystem are incredibly high. Literally everything has to be calculated.
Okay, let's dive into this. Here is our chronological blueprint for today. We'll start with concept and feasibility, move into engineering the ecosystem, do an installation reality check, transition from build to biology, and finally, wrap up with mastering ongoing maintenance. All right, first up, Section 1, Concept and Feasibility, Establishing Your Reef Goals. So your visual goals, say you want a massive open sandbed, or maybe a stunning room-dividing peninsula. Those aesthetics literally dictate the math we have to do next. Before you even look at a single fish or coral, you've got to do the dry math. You really need to assess the physical space with ruthless honesty. Like, what is the floor load capacity? A custom reef tank is incredibly heavy, and, nobody wants their living room floor joists to snap and create a surprise basement swimming pool. You also need to look at utility access. Where is your electricity, water top-off, and drainage going to go? It's absolutely crucial to establish a realistic budget right out of the gate and figure out if structural modifications to your home are needed before you move forward.
Once all that math checks out, we move to Section 2, Engineering the Ecosystem, Layout, Filtration, and Flow.
Okay, so we're transitioning into systems thinking here. If the tank is the body of this ecosystem, while the plumbing and the flow are the heart and veins keeping everything stable and alive, proper water movement is just non-negotiable for oxygenation and preventing dead spots. So let's talk about the filtration engine hidden beneath your tank, the sump. When planning, you have to weigh an off-the-shelf standard sump against a custom or hybrid build. A custom sump is a real game changer because it allows you to design specific compartments tailored exactly to your tank's needs. You can dedicate exact dimensions for high-end skimming, or create a refugium, which is essentially a safe zone for beneficial algae to naturally export nutrients out of the water. It's all about matching that filtration capacity directly to the specific biological load you plan to carry.
And then, of course, there's the lighting. Now, a big misconception here is that lighting is just about making the tank look good for photos. Actually, scratch that. Lighting is entirely for biology. You absolutely have to match your LED fixtures, your mounting heights, and your light acclimation plans to the specific coral types you intend to keep. I mean, a setup designed for low-light soft corals is fundamentally different from a rig meant to sustain demanding, high-light coral species.
That brings us to Section 3, the Installation Reality Check, Build Design and Materials.
This is where the project moves from paper to the real world. One of the most foundational physical choices you'll make right now is your tank material. Acrylic versus glass. And it's a serious trade-off for sure. Acrylic is lighter, yeah, but it scratches much easier. Glass, on the other hand, is significantly heavier and can be really tough to maneuver, but it's highly scratch-resistant. You definitely cannot take this choice lightly. It doesn't just impact your total cost, it completely dictates the delivery timeline and the entire fabrication process.
Let's look at how the vendor timeline actually plays out. First, you'll specify your custom tank and cabinetry, making sure it's sized perfectly for doors and wiring. Then, you wait out the fabrication process, but here is where a lot of people get tripped up. Long before delivery day, your on-site readiness checks absolutely must be complete. You need to have confirmed your cable management paths and ventilation for your electrical components way before that tank ever arrives at your door.
Then comes installation day, which, let's be honest, is always a bit nerve-wracking. You're setting the stand and verifying the leveling. If it's off by even a fraction, the pressure on the glass can be catastrophic. You're routing the plumbing lines specifically to minimize friction losses and vibration. You're doing a crucial leak test with fresh water before you even think about adding salt water. And finally, verifying electrical safety by ensuring GFCI protection. These are essentially safety switches that kill the power immediately if water ever hits an outlet. Even perfectly designed systems require these on-site reality check adjustments just to fit the specific room.
Assuming you pass that leak test, we enter Section 4, From Build to Biology, the Magical Pivot.
Now, what's really interesting about this transition is that once that tank is finally filled with salt water and the plumbing integrity is fully verified, everything changes. The whole shebang. The timeline shifts entirely from build to biology. You're no longer acting as a mechanical engineer turning wrenches. You are now cultivating a delicate, living ecosystem. The priority shifts completely from structural integrity to biological stability.
And that biological stability starts with the cycling phase. This is an absolute necessity, guys. You are establishing colonies of beneficial bacteria that will process harmful ammonia and nitrite into safer forms. Think of it like this. Without this invisible army of bacteria established in your rock and filtration media, any livestock you add simply will not survive. Rushing this phase is incredibly dangerous, and it practically guarantees early losses.
So, during this phase, you are looking at an intense testing schedule. You've got to monitor the big ones, ammonia, nitrite, and nitrate, right alongside your pH, alkalinity, salinity, and temperature. I want to remind you here, a custom system is entirely dependent on keeping these exact parameters strictly in line. It requires true, absolute diligence. You're basically watching the invisible chemistry of the water slowly balance itself out.
And this brilliantly illustrates how stocking your tank requires meticulous staging. You spend those first 4 weeks purely on cycling and bacteria establishment. By months 2 and 3, you can slowly introduce hardy organisms to support a balanced system. It's not until month 4 and beyond that you start introducing delicate corals, but only once stability is truly demonstrated. Patience here heavily reduces the risk of those heartbreaking early livestock losses.
Finally, we reach our last stop. Section 5, Mastering Ongoing Maintenance, Designing for Human Reality.
Here is the truth. A perfectly engineered ecosystem only survives if the human caretaker can actually maintain it. You have to design for human reality. For example, your strategy for skimmers and filters might be routine cleaning, but the human reality means you need clear physical access to the sump to actually achieve that. For nutrients and alkalinity, you might rely on automated dosing, but you still need reachable test points for periodic calibration. And for heaters and flow, sure, you use controller monitoring, but you still need organized wiring channels. It's a striking contrast, really, between modern automation and the manual checks that are still strictly required.
The absolute biggest takeaway for maintenance is this. Make sure your valves, filters, and service points can be reached without having to dismantle your beautiful display. A little organized wiring prevents a minor troubleshooting chore from turning into a stressful, day-long nightmare tangled in a wet rat's nest of cords. Designing for human access is honestly the real secret to long-term enjoyment of the hobby.
So, I leave you with this final, provocative thought to ponder. Is your plan clear enough to turn a mechanical build into a thriving, stable reef? Because at the end of the day, custom reef success comes down entirely to how well you plan for stability and ongoing maintenance from the very first sketch. Thank you so much for joining me in this explainer, and I really hope this gives you the blueprint you need to build the ocean of your dreams.